67, number of arithmetic triplets. So for this problem, we're going to solve it by using On time complexity. And for the space complexity, first of all, we're going to use the On as well. So let's try to solve it first. So we're going to use a set. This means the space complexity going to be On, and time complexity going to be On as well. So we're going to check the numbers one by one. So for N inside of the nums, if because according to the definition, if we find this number, this N, we're gonna set it as the mid number. So we're gonna be the N gonna be the second number. So what's gonna be the first number and the third number? So if N minus diff inside S and N plus this diff inside S as well, we're gonna update the final result, and finally we just need to return the result. So this is, as you can see, definitely this is going to be On time complexity. Let me think about it. Because the S going to be a set of nums. Because I want to check if it is inside, definitely this is going to be On time. Now we want to use another way to solve the problem. We want to use the three pointers to solve the problem. Basically, three pointers for most of the problem. If this is three arrays in increasing order, definitely we're going to prepare three pointers. So this is going to be the first pointer at index 0, and the second one, this is going to be index 1. This is going to be the second pointer, and then we're going to enumerate the third pointer, which is going to be, for example, this is the I and this is the J, and we're going to enumerate the third pointer, which is the K. So while we are enumerating the third pointer, the second pointer and the first pointer also just increasing. So the third pointer is also increasing. So this is just On time. So for our property is that, for example, if this is the third pointer K and this number is X, and if this so while we are enumerating this number, this is going to be a for loop. So we want to check the second number. So for example, the second number is nums J. If nums J plus this difference plus D and less than the current enumerated number X, so this means the pointer J is too small. We need to update the pointer J gonna plus equal to 1. So this is the main idea. If it is less than X, so J gonna plus equal to 1 until it equal to X. But if it is more than X, so definitely we will continue to check the next to enumerate the next index, to enumerate the next K. And similarly for I. So while the first part is possible, so for example, this is going to be the first part, so it's going to be nums K minus nums J, which is equal to the diff. If the first part is possible, and then we're going to continue to check the second part, if this nums J minus nums I equals to diff or not, and it is just the same idea. Now let's just use this algorithm to solve the problem. So we're going to prepare a final result, and I and J. So the result is going to be 0, and I going to be the first index, and J going to be the second index, so which I going to set it to 1. Now we're going to check the nums one by one, so this is going to be the third number. So if nums J plus the difference is less than X, because all the numbers is unique and it is in increasing order. So if it is less than, so this means J need to plus a 1. So we're going to need a while loop to check. So while this is less than X, so definitely J gonna plus equal to 1. Now we're gonna have a check if nums J plus diff. If we go out of the while loop, but it is still not equal to X, so what are we gonna do? So if it is still not equal to X, so we're gonna continue. We just want to check the next. Because currently, if it is smaller we're gonna update it. But after that, if it is not equal, so this means it is more than x. So it means definitely we didn't find it. So we're gonna enumerate the next value, which is we're gonna enumerate the next x. So which is why we're gonna continue. Yeah. Now similarly, we're gonna check the nums I. If nums I plus the diff. So from here, this means we've already found the first part, and then we're gonna find the second part if that is possible. Yeah. So while nums I plus diff is less than nums j, so I gonna plus equal to 1. Now we need to have a check if nums I plus diff equals to nums j. This means we've already found it. We're gonna update the final result, and finally we're gonna return the result. Yeah. As you can see, it works. Now let me just submit it. As you can see, it works and it's pretty fast. Why this is better? Because for this algorithm, we didn't use any actual space, so the space complexity is O1 and the time complexity is On. Thanks for watching. See you next time.